Now we will prove Coulomb's law from Gauss' law. Earlier we used Coulomb's law to prove Gauss' law, but now we will go in reverse direction. That means using Gauss' law we will obtain uh, Coulomb's law. How to prove it? Let us imagine a point charge situated at some point whose magnitude is plus q. Now construct an imaginary sphere whose center is at that point charge with a radius r. Consider a small patch of area ds. Therefore ds vector, area vector, which should be perpendicular to this area surface patch ds, must be along radial direction. What about E? Due to isotropy of property of space, that means all directions are equivalent, it cannot be in any other direction. It should be in radially outward or radially inward. For example, if you take, say this as this may be the, you imagine this may be the E direction, but why only this direction should be selected? There are infinitely many similar directions are there, which makes an angle theta with this radius vector. Therefore, why only this should be selected? We don't have any answer. Therefore, due to principle of isotropy of space, it must be in radially outward direction. Therefore, at any point this E dot ds will become, since they are parallel, E, that's magnitude, into ds. Now one more thing we will use is fact that at any point on this sphere magnitude of E must be same. Why? Once again, that is due to isotropy of space. If magnitude is something different at this point, let me say E is equal to say 1 unit, and here if you say E is equal to 0.75 unit, that's wrong, because then we can say this direction is not equivalent to this direction, which violates the isotropy of space. Therefore, now we have two facts. One is this one, E ds. Then second fact, due to isotropy, E must be same in all points. Must be same in all points. Therefore, that closed surface integral through the spherical surface E dot ds will become surface integral E into ds. Now no vectors. From Gauss law, that must be equal to q into epsilon naught. Since E is constant at all points on the surface, only magnitude, not direction, thus this integral can be written as E can be taken outside the surface integral, E surface integral of ds equal to q by epsilon naught. Now what is the meaning of this small patch adding, that means integral? That is, we will get whole surface area of the that spherical surface. And what is that spherical surface area? 4 pi r square. Therefore, electric field magnitude at any distance r is given by this one, q by r square. We will make this one equal to q by epsilon naught, then doing some massaging there to that equation we will get this one. Now let us put another charge q dash on this surface at a distance r. Then the force F that acts on this charge is q dash into E. F is equal to q dash into E. Therefore, it will be read like this. If if you do that one, it will read like this, which is nothing but Coulomb's inverse square law, which was experimentally observed. Now we can prove it from the Gauss law. Now discussion on the equivalence of two laws. Okay. Coulomb's law is written as F is equal to Q dash E 1 over 4 pi epsilon naught Q dash R square into R cap holds good only for point charges. Remember, it holds good for only point charges, and it can be extended to surface charges, volume charges and line charges if we use superposition principle. But superposition principle may not be valid in very high intensity or high intense electric fields. Gauss law and Coulomb's law are logically equivalent in the case of electrostatics. I don't know when charge moves what happens. Coulomb's law is not valid, and Gauss law is obtained from Coulomb's law in the case of electrostatics. Therefore, I don't know which law will be valid or can be generalized into moving charge case also. But this equivalence is not valid when field and charge distributions are varying with time. Okay. However, Gauss law in differential form, not in integral form, Gauss law in differential form is always valid. It is experimentally found fact. Therefore, we will make it as a postulate. Gauss law in differential form is always valid if we consider the charge density and electric field at same point and same instant of time. Okay, same point. At this point only, if you want to calculate what is divergence of E, this is the differential form, and rho by epsilon naught, that is the charge density. At same point they are related, but at same instant of time also. If it is at 12 o'clock and it is also at 12 o'clock, then okay, divergence of E is equal to rho by epsilon naught. That is guaranteed. Therefore, this is the most general form of the variation of electric field. Now let us have a quiz. While using Gauss law to find electric field due to a point charge, we start with the fact that electric field is in the radial direction. To establish this fact, we used what properties of space? We are using the fact that all moments in time are equivalent. This is one option. We are using the fact that all directions are equivalent. This is another option. We are using Coulomb's law to tell that E must be in radial direction, proportional to radial vector. To establish this fact, what we have used? Option 1 I have already read. Option 2, we using the fact that all directions are equivalent. We are using Coulomb's law, or else we are using the fact that all points in space are equivalent. Which one is your option? Yes, this is the right option. We have used all directions are equivalent. This is the principle of isotropy. Another one is based on the Coulomb's theorem, not Coulomb's law. Electric field at point P just inside the conductor and at a point Q just outside the conductor are given by dash respectively. See, this is the conductor and inside it is conducting medium, and here is a point, let me select blue, Q. Here is the point Q and here is the point P. Now I want to calculate the field, and here the density is given and that density is sigma. Then what is the field at Q, P and Q? Is it 0, 0? 0 and minus sigma by epsilon naught, 0 and sigma by epsilon naught, minus sigma by epsilon naught and sigma by epsilon naught. Which one is your choice? Yes, you are correct. That is 0 and sigma by epsilon naught. Option C is the right answer. Let us have one example. In this problem, you are asked to find out the volume charge density at any point inside a region where electric field is defined by electric field E is equal to 5xi, 6yj, 3zk. I will give you 3 seconds. You have to tell me what law or property I should use. Yes, you are right. It is Gauss law in differential form. Gauss law in differential form. By differential form, we have divergence of E is equal to rho by epsilon naught, and I am asked to find out Mr. Rho. And divergence of E for our electric field is 14 units. And rho is nothing but epsilon naught into divergence of E. Substituting the value of epsilon naught we have and divergence of E is equal to 14, we have 1.239 into 10 power minus 10 coulomb per meter cube, assuming this is small meter cube, assuming these are in the right SI units. We will have quiz. Now, two persons are sitting inside a completely closed house. Each has 8.85 picocoulomb. What is the flux through the surface of the house? House is like this, completely closed. All windows and doors are also closed. And here our friend is Gauss law in integral form. Total flux pi, outward flux pi is given by net charge by epsilon naught times. Here each person has positive charge 8.85 picocoulomb. 8.85 picocoulomb means 10 power minus 12 coulomb, plus another person also has same amount of charge into 10 power minus 2 coulomb divided by epsilon naught. We have chosen this value so that exactly numerically equal to epsilon naught values. 8.85 into 10 power minus 12 divided by same number 8.85 into 10 power minus 12, and net charge is twice this one, therefore this got cancelled. It is 2. What is the units? Joule meter per coulomb. You work out, right unit will be like this. Now we will have multiple choice answer questions like this. To obtain differential form of Gauss law from its integral form, we have used Stokes theorem, Gauss divergence theorem, Carnot's theorem, Coulomb's theorem. I will give you 3 seconds. Yes, you are right. Gauss divergence theorem we have used. S is a closed sphere of radius r and centered at origin. Only 5-10 nanocoulomb charges are present and are at distances greater than 4r from the origin. Then the total electric flux through the surface S is, give you 2 seconds, answer is A, 0. Why? Because all the charges are outside the sphere. They are at a distance greater than 4r, therefore they will go out of the spherical surface. No charge is lying inside, therefore 0 flux. Suppose the electric field in some region is given by E is equal to xi plus 2yj plus 3zk, then charge density over that region is. Here we have to calculate rho. For that we will use epsilon naught into divergence of E. And options negative and uniform, non-uniform, 0, positive and uniform. Right answer, you check it out, this one.